Today I'll be talking about containers and not only their basic functionality and properties, but also doing some more advanced operations with containers with some simple examples. So we'll just, yeah, I'll go ahead and get started now. And like all webinars, feel free to ask questions using the chat. And also you can check out our webinar archive online in our library to view recordings of past webinars. Okay, so this model that we're looking at right now is just a simple model that has one, it's a model of a lake. And I chose a lake because it's quite common in a lot of GoldSim models to have storage facilities, whether that's for water or for some other material or something, and then have these things talking to other components in the system that are similar to it. So, for example, a network of ponds and tanks, for example, is something you might see quite commonly done in GoldSim. But it could, the concepts I'll be talking about apply to any kind of GoldSim model. It doesn't have to be this particular thing. It's a model of a system of components that are real. Well, it doesn't have to be that. So what I'm saying here is we have some objects. That's probably a better way to say it in a more abstract term. We have objects that we want to simulate, that we want to include in our model, and they as a whole represent a network or a system of interconnected components. So it's very common to have this kind of a requirement in a GoldSim model. And therefore, it is important to use containers in a way that help you represent these kinds of systems. And still to this day, even though I kind of harp on this this concept quite frequently, we still see a lot of models where end users are not making the best use of containers for this. So that's why we decided to talk about this. So a lot of things you might see today are maybe more of a review, but hopefully there's some new things here and there that you'll see for those of you that are experienced GoldSim users. Okay, so what I have here, imagine that you have a lake, and in fact, I want you to imagine that we have two lakes, and water flows from one into the other. And so right now I'm showing one lake, it's called Crystal Lake here. It's in a container, and you can see over here on the left in the browser, there's a bunch of elements that are nested inside the container. You can see I can collapse and expand this. Yeah, so this represents a bunch of functions that are inside of it and data. Right, so if I go into the container, and you can do that by clicking on this little arrow in the top left corner. Some people think that's hard to get to, and especially it's hard if you're not using a mouse. So if you're just using the pad on your laptop, for example, the finger pad thing, this becomes difficult to do. So we have a workaround for that, not really a workaround, but we have a shortcut, and that is to hold down the control key on your keyboard and then just double click the container anywhere. You can click anywhere on the icon. So I'm not sure if that's new to anybody, but you can also use other keyboard shortcuts, such as holding the Alt key down and then using your arrow keys. So up arrow goes up. That just brought me up. I just navigated up. And you can't go down though, but you could go back. So Alt and then the left arrow key takes you back to where you were before, and you can go forward. And there's probably some others there, and then there's also these buttons up here, home, up, left, back, forward, kind of like on a web page. And then we have the address bar. Don't forget about the address bar. It's very useful. It has a lot of capabilities. So for example, let's say I have another pond over here. Let's see, container, and let's say this one is called Apple Lake over here, right? So now we can use the address to go navigate into, the address bar. We can navigate into either Apple Lake or Crystal Lake just by using this little drop arrow thing. So it's really nice. Another thing you can do is you can copy the address up here to the clipboard by right-clicking, copy to the clipboard, and then if you're somewhere else in the model at any point, you can then right-click and browse to the path from the clipboard, and it takes you there. So that's kind of nice for navigating around in the model. Another thing I like to do is I like to use the note pane, and depending on the orientation of your GoldSim model, if it's wide and not so tall like this, like what we're seeing, then, oh, and I just need to make sure nobody's having any issues viewing my screen, it looks like, right? Okay. So if you have a note pane open, then you could say, here's my, you could have formatted text to describe your model. And then I'm just putting some random text in there, but just to show that you can format this text, for any container that you're in, and then you could, copy this and put that onto another container, and then call this. And the reason I like to do it with the note pane is it gives you the ability to kind of maximize the space that you're working in with elements, and then have notes in a different place that could be moved, which is nice, right? It depends on the orientation. What if you put GoldSim in a situation where it's half the screen? So if I do this, where it's half the screen, obviously the note pane is taking up too much room there. So we could do something like this, where it goes up at the top, and then we could move this like this. So the nice thing about the note pane is you can move it around, and then it could be a nice way to document containers, because now when I go into the container and I'm looking at this, it shows me still at the top that, oh, this is Crystal Lake. We could also put it at the top right here if we wanted to, but I'm putting it over here on the side. Okay, so anyway, just wanted to make sure you knew that. You can also put other, you can put lists in here. You can even copy and paste tables into here for documentation. You can't paste images, but you can paste any kind of formatted text into here, which is really nice. Hyperlinks and stuff too. Okay, so the basic functionality of the container is really just to organize your model. That's the most fundamental and basic way to use it. In fact, you have to use it that way by default if you don't do anything else with the container. But if you don't do anything else to it, and you're trying to use containers to represent objects like I'm doing here, I have two lakes. I want to represent these two lakes with these containers. We start to have problems if the model gets larger and larger in this case. So let me talk about some of the issues that you might run into here. Let's go into Crystal Lake. I'll go in here, and here are all of these elements. We've got a combination of things going on. We've got data, we've got input data in various forms, and then we also have outputs that we're interested in, and in various ways too. So let's talk about the inputs. On the input side, we have a lookup table, we have a constant, and we have a stochastic. In your case, you probably have something similar, also maybe some time series elements and other things. So these are like, you could consider these forcing functions, or these are influencing the model to behave in a certain way, right? But specific to this object. So these elements, these inputs here are really meant for just this object here. But we might have some expressions in here, like the way that we calculate lake evaporation, that are common to all the other objects in our model. It's important to understand that you have commonality, right? That you're reusing as much as you can to try to keep things, to try to prevent yourself from having to repeat calculations over and over. So in an effort to try to leverage containers in a way to not repeat yourself over and over again, what we want to start looking at is, starting off anyway, is localizing. That's going to be the low-hanging fruit, so to speak, in trying to maximize benefit here, and that would be localizing the container. without localizing the container, what that means is all of the names you see in here are global in scope. Everything here, every name in here, these element IDs, they must be unique throughout the entire model globally, because there is no localization. These names are broadcast, or they can be found outside of this container just by a direct link to exactly that name. So what I mean by that is, if I want to, let's say I want to reference outside the volume in Crystal Lake, well, that means I need to point to this element, the main output of this element. Um, and also, you see, we have a sort of a strange thing going on here. The container name is crystal underscore link, right? And this element also wants to be that name, but I can't make them the same, so I put an underscore at the end. And you might do other things. Maybe you abbreviate it or do some other thing, right? But ultimately, you're trying to say, well, this is the lake output. Well, maybe we should think about it a little bit different way, because now what we're starting to see is, well, this inflow, this stochastic element, this is also unique to Crystal Lake. So I need to put Crystal Lake on this name somehow to differentiate it from the other lakes in my model, right? So you might put a CL to abbreviate, because it might get tedious to type the name Crystal Lake after everything, right? Same thing with evaporation. Same thing. I mean, everything in here is unique to Crystal Lake ultimately, even though you might have the exact same equation in other places. So this becomes tedious and redundant, and I still see this quite often, and I would hope that you could find a way not to do this, because um, while it does give the name a unique identifier that can be found globally, that is asking for potentially more the potential for more user error. Becomes harder to find things, and it's just less organized. But also, most importantly, it distracts us from the concept of an object-oriented layout and foundation in our model. That's what we're shooting for, because that will make it the easiest to scale up and work with and read the model. Okay, so let's talk about now what happens if I localize this. Just going to save the model. What happens when I localize this container? Well, let's talk about the properties of the container first. So I'm going to double click on this container, right? That goes to the properties, right? Double clicking always goes to properties of elements. That's what it does. And so that's why I had to mention at the beginning that you need to hold down the control key if you're going to enter into or navigate down into this container. And that would be by holding the control key, right? Okay, so double clicking the container is just the properties. We go into here and we see that there's these list of features with these check boxes. And that's how you enable localization, is the first feature called localization. So if I check that box, then you see the container icon now changes to look like a closed box. So now that we did that, we should take a look at the reference to an output inside of Crystal Lake. So now I'm opening up this expression to see that expression in there, and it says it's crystal underscore lake dot outflow 1. So what does that mean? That means it's referring to the name of this element, Crystal Lake, and then if I go in here, it's referring to the outflow 1 output of this element, which is buried inside of the element, by the way. And you can find all the outputs of any element by clicking on the output port just to the bottom right of the icon. So if I click on the output port here, it shows me all the outputs available, including the folder of all the outflows that you can custom add and edit and delete from the outflows tab of the element. This is the nice thing about using a pool, by the way, right, as opposed to a reservoir element. So here's outflow 1. It's one that I've defined in here. We can go look at it by going to the properties of the element and going to the outflows tab, and you see there's outflow 1. Now I just put in a constant, but in a real model you would have an expression there that's a request, right, that you're making on this. But the outflow output is buried in this element here. Probably, I think a better way to do it would be to add a new expression. So why don't we just go ahead and do that? I'll add a new expression here, call this outflow. And I am making this name generic on purpose because I'm imagining in my mind that I will have more lakes in my model that have a very similar structure, right? And they will also have an outflow output. In a real model, you would maybe have multiple outflows that have different names to them to describe the type of outflow, like pumped outflow, or uh, um, maybe there's uh, an outflow that's maybe specific for some purpose, or maybe there's an outflow that you calculate that's a spillway flow when the water level is too high, or something like that. Anyway, you would give these names and then just refer to them. They're coming out of uh, the pool element. And I don't remember the units I was using here. I'll just say liters per second. It actually doesn't matter as long as it is a volumetric flow unit, right? Because that's what I'm working with here is water. Okay, so then I go over here to reference Crystal Lake underscore dot, and then I go to outflow 1, and there we have the output of interest. So then I go back, navigate back outside of Crystal Lake, come over here to this expression, and now I want to refer to, you see it still says outflow 1. I want to just refer to the new expression I created in there. So I'll navigate into Crystal Lake and find outflow, the new expression. There it is. And it says, as soon as I say I want to add that output, it says, oh, this output is not exposed. So if you haven't, if you're not familiar with the concept of exposing outputs on containers, this is important. This is an important concept in GoldSim because only outputs that are exposed can be referenced by just typing the names, without actually going through this process of doing a link like this. That has some benefits just for ease of operating within the context of these elements. For example, accessing specific outputs of these, like you're working with objects. If we look at Crystal Lake, we want it to perform. We want it to act like an object, act like a real thing, right? That's the purpose of modeling it. So this Crystal Lake container should have attributes that we can access. Things like what's its current water level, what is, in our case right now, what's the outflow, and we want to link to that and use it in other places in the model, right? So we want to be able to work with it like it is an object. And so by exposing the output now, we can simply, now that it's exposed, we can reference it in a certain way. And let me just mention exposed outputs. If you go to the properties of the container, you'll see there's an exposed outputs tab. So if you haven't seen this tab before, I recommend going there and looking at this in your model. See if you have things in here that look confusing, or maybe you don't have a reason for it to be exposed. Then you could remove it. You can also add additional ones to this list. And once they're added to the list of exposed outputs, now it's very convenient when you're typing and finding attributes of the container, or in our case, this object. So when I go back into this expression, I want to now, just by typing, now I want to refer to that outflow. So first I type the name of the container. So there it is, first on the list. So I'll just hit the tab key. That auto completes. And obviously it's not finding anything here because all I'm doing right now is referring to a container. But if I hit period character, now it shows me a list of all the exposed outputs on this container. I want the first one. That's the new one I just created. Okay, there we go. Now it makes the connection. If I double click on the hyperlink, it shows me I have an outflow output inside the container, and it's going to the Crystal Lake outflow element expression out here. Okay, so now that we have a localized container, now we can go in here and we can make everything generic and referring to a commonality between all of our other reservoirs and ponds we might have in this model. There might be some things that are not the same, and that's okay because we're not doing anything like cloning. That's a whole different subject. But it is possible, by the way, to clone containers so that you can sync changes that you make to elements inside of the container. Any new element or changed element I would do in here, for example, would be immediately synced to all of its cloned containers, which can be very powerful. But it's another, it's a kind of a big subject, and we have other examples, we have other webinars we've done on this. I just didn't want to get into it today. So the nice thing about having a localized container is, yeah, you can treat this as somewhat as a as like having a class in a programming language. In a class, you can instantiate objects, and they have attributes and functions, right? And that's the same way that's what we're trying to mimic here in GoldSim, using localized containers. And so right now, I have something that's pretty generic except for the name of this pool. So I should probably just change this. For now, I'll just change it to pool. It represents the pool of water, and it does have some other attributes, but I'm choosing to reference these other attributes outside in another expression. Doing a reference like this should not add a significant overhead to your model if you're doing a lot of these. So I would say err on the side of being more verbose than not, or more descriptive than not. So to be more descriptive and more transparent to the reader of your model, it would be a better idea to have an expression just like this outside of your pool element to refer to an output there. It's not an equation, right? It's just a reference. This is useful because it just gives a visual to your end reader, to your audience that's looking at this model. They look at this and they say, oh, okay, this must be like, where all the outflows are. And you could even, draw a box around this or put a text here, say, here's all the outflows, right? And kind of move them into an area and kind of highlight that. It's a good idea. Also, it's very important when you're inside of a container, look at the ports. And this is not something that it may not be something that you learned when you first started using GoldSim. And so I always try to make sure that people see these things because they can be quite useful and give you hints and kind of help you along the way of reading a model. So notice the pan evaporation rate and this inflow both have a left input port with a dot showing. Okay, that's telling us something. And you see over here where it says outflow, there's an output port. That's the port on the right with a dot shown. If I put my mouse over the element, you see that there's a port that appears, and that's just a way for you to know where the port is. The ports always exist. Input port means this is going to show you the inputs, the input definition, essentially, to this expression. Some elements are a little bit different. Like the pool element has quite a few, and you can see that it put the windows over here. Move that over a little. Okay, so the pool element, you can see it has many inputs. It has all these inflows. Now you can have a list of inflows. I only have one, but imagine you could have many inflows, many requests, and so you'd have a big long list here of attributes. These are, input definitions. And then on the output side, as you know, it has a lot. But anyway, it's important to keep in mind that you have those things. But what does it mean when you have a dot here? What it means is that there is an influence coming from outside of this container, above, actually, is what it means. And I shouldn't say above. Outside of this container is the right the way to say it, because if you had a container inside of this container, let's say we have another container in here, right, and it has an output that we're referring to for evaporation up here, let's say, well, then there would be an influence line pointing right here. That's what would happen, and you would not have this dot. This dot tells us that there's an influence coming from outside of the container, and we can either click on it here and just put the cursor over it to see what the equation is, right? Obviously, or we could just go in and see what the equation is. But what we're seeing here is that we've got a lookup table that's referring to a run property, right? This is a simulation run property, and so there's two run properties actually that it's referring to, just to be able to get us to look up the right month and get it into the right units. in this particular case. So one thing you can do is go over to the browser, right click, and choose show element subitems. And then up here, it kind of resets the browser, but you can re-expand some of these things here. But the local properties is what we're interested in. On the calendar time, you can see that month is being used. It's got a little blue symbol as opposed to gray, and days in month is being used down here. And those happen to be the two properties that we were looking at in this expression. Okay, so this element is referring to global run properties of this model. And because it's referring to global properties, those are outside of this container. And that's why it's got a dot here. And then this outflow is being referenced as an output to some other element, other elements input outside of the container. So it's showing a dot. And we already know this one is being referenced by this expression I have out here. Okay, so that's the benefit of localizing containers. So what we can do then is we can say, oh, I want to, expose another output. I'm interested also in seeing what the current volume is of this lake. So I might add another expression here that's called Crystal Lake volume. I'll do cubic meters. And now if I start typing Crystal Lake and put a dot, you see I don't have a volume output. I also happen to have this outflow 1 straggling on here that I don't want. So let's first get rid of the outflow 1 straggler there. So I'll go into Crystal Lake, and there's a couple of ways to do this. This is one way. You can go in to the container and go to the specific output that you don't want to show up as an exposed output, and then you find it. Here it is. I can right click, and then you see there's this exposed output option on the context menu when I right click, and then I can just click here and it unchecks from the exposed output list. So now when I double click on the properties of this container and go to exposed outputs, you see it's gone. Similarly, I can add exposed outputs in the same fashion using the right click method. I'll go back into here. Now I want to show the volume. It turns out that the pool is the volume. That's the main output of the pool. So technically you could put another expression over here that says, volume, but I think that's going a little bit too far. I think I'll just refer to the pool as the volume. So they'll come out here to the outside and refer to it. Oh, but first I need to add it at this main output as a exposed output. So I'm clicking on the output port again, and I'm going to the main output called pool. Right click. Crystal Lake is what it's exposed on, and I can do it again just to make sure. There it is. It's checked, right? Okay, so now I come up, and now what I can do is I can type in the dot next to the Crystal Lake dot, and now you see it shows two options, outflow or pool. And so now if I go back to the properties of the container and I look at the exposed outputs, you can see there's outflow and pool there. Okay, so that's useful. You can also work with exposing outputs through the port interface. So I can click on this output here, output port, I mean, and now I can see all of the available outputs. Maybe another thing I want is, maybe the water level. So I would go over here, and it turns out to use the right click functionality to expose, it turns out you cannot do it on just the name of the element. So you can see if I right click here, nothing happens. I'm right clicking, nothing. So if I expand this and then click on the actual output, when I say actual output, it's the thing that has the symbol with the triangle. And then I go to expose and I can expose it. So now when I go to the properties, exposed outputs, we see 3. So that makes sense. So this is useful because now what I can do is I could make a copy of this for the other lake. I'll just delete the one I had there and go ahead and copy this. And the great thing about this is now we have the capability, now that we've built this framework, we have the capability to scale up our model quite quickly. And so now we can do it by just simply changing the name here and here. We don't need the 1 anymore. Okay, so I go into here and everything's ready to go with exception of the plot. So the plot is using a name in the title that I don't want. But other than that, everything is ready to go. Well, I need to change the input data, obviously, right? And whatever other functions I might need, but we've already got that taken care of. Now I can just, we've already got the framework taken care of in order to um, uh, quickly build these up. So one thing I wanted to just show is that, okay, now it's really easy to make the connection of the flow from Crystal Lake, which is this one, going into Apple Lake. So instead of using this stochastic element called inflow, we can just wipe it out, delete this element, which would not remove, by the way, the reference here. We want to keep the reference. So when I delete inflow, now if I go back into the pool and look at the inflows, you see there's this hanging, dangling reference that has nowhere to go, so it's an error. That's okay, we'll just create a new expression because I'm just replacing it, right? So I'll call this inflow again and make sure I have the correct units so that the connection can be made. Once I have the correct units and I have the correct name, that's all you need. I can type the key, the F9 key, to update the expressions, or I can go up here to model, go to update expressions, and as soon as I do that, you should see a GoldSim draw and influence line there. And there it is, inflows, the connection is good. Okay, so now I'm just referencing that flow rate outside of the model, Crystal Lake outflow, like that. I go up a level. Now you can see I've made the connection. So this is one way to make a connection from one lake to another, is to have, this kind of intermediate linkage right here, but it's not necessary at all. And the reason I say that is because of the use of localized containers. So you might come in here and say, well, I like having that intermediate expression because look, I can see exactly what I'm going after right here, Crystal Lake outflow. My argument would be, well, because you've used localized containers, you can do the same thing. So if I click on insert link and then I drill into the place I want, I can do that. Or same thing as before, right? Crystal Lake dot outflow, very simple, straightforward. If I go up a level, you'll see that I've bypassed this thing completely. I can just ignore it, delete it. And now if I double click on the influence line, what we're looking at now is we have an output in Crystal Lake / outflow, input, Apple Lake inflow, right? It's very crystal clear, to understand the flow logic between these two objects. So this is a really big benefit, and it is seemingly elementary as far as GoldSim goes, but these little things, being able to use these tools as you go and as you build, really can make a big difference, especially in a bigger, more complicated model. I wanted to make mention of some other aspects, other features of containers, but just briefly. So we have conditionality. The conditionality, what it can do is, if you check it, it adds another tab called conditionality. You can also combine some of these object properties, by the way. You could have it be a conditional container and also looping, or and also internal clock. I don't think you can do all three, but you can combine them like that. Hopefully you don't need to do a model where there's all three, but you could nest another container inside to have additional functionality, but hopefully you don't have to go quite that far. These options are already quite complex in what we're trying to what you're trying to represent. So it's important to walk through these one at a time and fully understand them if you need to use it. Conditionality adds this new tab, and this just allows you to essentially trigger it when to become active. If it's not active, then nothing inside the container gets updated. Now, I'm not saying that it doesn't have results if it's not active. You will see results. It will. You can link to it outside the container. You can link to inputs and outputs outside of here. So for example, if I wanted to see a time history of the water volume inside of Apple Lake, then I would just refer to it like this, right? And so, oh, by the way, when you're referring to outputs inside of a local container like this, where you've made names generic, one area where it does require some manual editing is when you're referring to outputs outside. So out here, when you refer to an output, let's say from inside Apple Lake, it by default, or actually it only shows you just the name of the specific output. You have to hover over it to see where it's coming from. So in this particular case, we'd want to put the name right somewhere so we know what it is. Maybe just in the title is fine, right? Something like that. So just make sure you do that. Otherwise, you would lose the connection, right, visually of where this is coming from, unless you hover over this. Okay, so let's see. So we made that connection. Yeah, so you can still make a link, and it would just show a static number because nothing's being updated inside of this container, but it would still initialize. So if you had, let's say, for example, an initial volume in the pool, and then you ran the model and you said, don't ever activate this container, it would just have that initial volume and never change, for example. But it doesn't mean that it just doesn't have results. It will have results. They just won't be doing anything. And so the nice thing about conditionality is you could simulate something like a phase of a project. Maybe you have a new pond that doesn't come online until a specific event occurs. It doesn't even have to be a date. That's the most common, but you could have prerequisites, right? There could be other things that must occur first in the model, and you might want to simulate those. Maybe you have a project, a series of projects that must be completed, and you may not always know when those are completed. And so the nice thing about conditionality is that you can do a sequence of activations that would allow you to build or simulate phases of a project. We also have examples that come with GoldSim to show that, so that can be useful. Another one is, let me turn that off, kind of go one at a time. I don't want to do too many weird things. Okay, internal clock. The internal clock also adds a new tab, and this allows you to tell GoldSim what are the maximum time step lengths inside of, or what is the maximum time step length inside of the container. And in other words, it allows you to have smaller time steps than the main model, than outside. So this is useful if you have something more detailed or more complex inside of the container that you need it to calculate things and then report out or output values on the larger time step on the outside. That can be useful. Or maybe you have a bunch of inserted events being thrown inside of this, a bunch of events being triggered inside of this container. An example is a pool element has upper and lower bounds. Whenever those upper and lower bounds are hit, an unscheduled event might be generated, and that would be a good reason to perhaps encase that into a clock container like this, an internal clock container, because those events that might be occurring won't be broadcast to outside. But I do need to say that if you have ponds that are talking to each other with feedback, then you cannot isolate an individual pond in a clock container like this, because it is interacting with other containers. Therefore, they all must operate together. If one of these inserts a new time step, then all of its connections, all of its connecting lakes must also know what that is, know when that happens. So you'll notice this if you try to use these and you have feedback outside of this container, you'll get a message you can't do that. You'd have to put the internal clock capability outside of all of them as a kind of a parent container. That can be done. Okay, so that's internal clock. Just remember, when you're using internal clock, it means you can have smaller time steps inside of it that are smaller than outside of the container. You can't go the other way around. It doesn't mean you have bigger time steps. No, it only means you have smaller time steps inside. Looping is another one. Now we have examples for all of these, by the way, so I don't need to go into all the functionality, I don't think. Just trying to tell you where you might use it. A looping container is useful. What it does is it iterates and re-updates, recalculates everything inside of it when you trigger it to, sorry, not when you trigger it, and it does it every time that the model is updating. So in a normal case, it would be if you have, let's say, for example, a 1-day time step, then it would reinitialize looping on every time step. And then when it starts looping, that's all that's happening in the model is this one container is looping, right, in the sequence of events. Imagine it's going through all these loops and it must hit some sort of condition that would drop it out of looping. And so in the looping tab here, you have that ability. You can either make a while or an until. So let's say you use an until condition. So what you would say here is loop this until the reservoir volume exceeds some value, right? That would be one example. Another one might be you refer to the loop count. So the loop count is a built-in variable that is the counter, and it's called loop count. You have to use the tilde symbol to access it. That's this little squiggly. And then I'm just going to say when loop count is greater than 10. So we're going to loop everything inside of this container until it loops 10 times. That's how this thing works. But you could have a more complicated equation that is referring to something going on in here to generate, for example, an implicit formula, or sorry, a formula or an algorithm, I guess we could say, an algorithm that solves implicitly for some solution you're looking for. There are examples that come with software. You go up here to File, Open Example, you'll find a looping container example that does just that. So I highly recommend looking at those. That would be very useful. All right, one more thing, and that is graphical aspects of GoldSim. So let me first turn this off so we don't have looping. Okay. Sometimes people want to customize the look and feel. Maybe you want to show something that looks more like a reservoir instead of this box, right? So we have in our library, which I need to open real quick. So we have in our library, we have some resources. They're not the best. They're things that I think I created most of them with my limited graphical skills. And so let me go to the library. Okay, so you should see our library here. We have, let's see, I don't know if we put it in. Okay, here we go. Yeah, so if you go to our library, that's the Help Center here, GoldSim Help Center, go down to Modeling Tips, and then scroll down, there's this custom GoldSim element icons. The goal was to have more of these, but they take a long time to generate. So here are the ones I've generated, and they're not great, but let's say you wanted to represent a reservoir with one of these icons. Let's say this one that says dam right here. So if you click on the hyperlink, you'll see down in the bottom left corner, hopefully you can see that, it shows the reference to an EMF file. An EMF is what you need for GoldSim. So it's just a type of vector. It's called an embedded. I forgot, but it's a Windows product, and it could be a vector or a raster or both. But it's essentially a kind of like a package that includes a bunch of image stuff in it. And the best is a vector drawing. It's always better to have vector drawings if possible, because vector drawings are very compact, small. They're just a set of instructions that tell you what the image should look like. They're not based on pixels, right? They're based on instructions. So it's a very efficient way to display images and will not bloat your model. If you're inputting JPEGs and PNGs, bitmaps into GoldSim, it will make the file very large. So vectors are better. So that's how I generated all of these. These are vector-based EMF drawings. Okay, so what you do is you just click here, and then you should see a download happen. There it goes. So now I will go and I will get that, and let me move this over so I can show GoldSim. Okay, so I'm going to my downloads folder. Well, okay, I guess I better show it this way. So here's the file I just downloaded, and so now that it's there, I don't know where it is. I can just come in here and import the image. So there are what I want to do is I want to make this container look like that, right? So you just go to the properties here, or you double click on it, same as we've been doing before, right? And then you go to appearance, and then image is the first tab. We don't want the default box. We want a user defined, so I'll go there, and then I'll go to downloads and grab it. And then I said yes to that message. Sorry, I just did that so fast, but there's a question there that comes up when you insert. Let me start over again. Okay. So this thing right here says the size of the current element, this container, and the symbol of the new one do not match. They're a little bit different, just slightly different. Do you want to adjust the size of the new symbol to match the existing? And I want to say yes, because I like everything to be the default GoldSim size, but you don't have to say yes. I say yes, and so it fits it into the exact same size and aspect ratio of the original container. But it turns out that what I generated in this library, these are all pretty, like, they're symmetrical, and they've already been kind of sized so that they fit pretty well if you say yes to that question. But when you generate ones on your own, just kind of keep that in mind. You want the thing to have a similar aspect ratio to the existing container. And if you want to know exactly what the container image is fitting in, you can right click on or go to the properties of the container and go to appearance, and then change the line to not be transparent, and that will show you exactly what the image is fitting in. So that's the space that the new image will fit in, right into that box, including the arrow. So that's why I did these round images that have a little bit of a white or a transparent border around it. You can't see it, but I created these to all have a transparent background and a little bit of a margin around these circles. And I like the circle because you can still see the arrow very well, and you can see the ports very well. I also do not like to change the default symbol of other elements, only containers. The reason I do only containers is because I want GoldSim's view or icon to show, because that tells us immediately what is this thing, what is this element at the most fundamental level. So I don't like to change the icon, even though you could change this icon right here, for example, right? Same way, just by user defined symbol. But I like to keep everything else all GoldSim, and then just change the containers. So I could do that with both of these and have them both show up as lakes. So anyway, that's just another kind of little side thing, not super important, but maybe useful in a bigger model. And that concludes the webinar. It's everything I had in mind to present, but I'm happy to answer any questions that you might have at this time. All right, if there aren't any other questions, then I'll close this. Thank you for joining. We do have our schedule for 2023 up now on our website, so take a look at what we've planned for the year. And we also welcome feedback and any other ideas, webinars that you wish you could see. Please do let us know. We would be happy to accommodate if that's something that we can fit easily in our webinar schedule. We can adjust things too. If you would like to volunteer to join us in presenting a webinar, we are happy to collaborate with you and help with the material and help you make that an easy process. That the presentations given by our end users are usually the most popular. So you would get you'd get a lot of eyes on your work that you're doing if you want to. All right, so I'll go ahead and stop now, and we will have another webinar next month. So hopefully you can join us then. thanks again and have a nice rest of your weekend.